So, good morning, all. This is Dhanlakshmi. So, today we are discussing about the Unit 2 of Design and Analysis of Algorithm, just nothing but the decrease and conquer and divide and conquer. So, first of all, the decrease and conquer means we have to reduce the problem solving by taking only the instance of the problem, and that solving the problem based on the solving the problem and combine the solution we have to get from the instance of the sub problems, and then we have extend the solution to the remaining problems. So this is what the basic concept of design and conquer. How the design conquer will be differ from the divide and conquer means, here the design and conquer is work based on the three steps. First, we have to design the decrease or reduce the problem instance to a smaller instance and extend the solution. Second, conquer means the problem by solving we can combine the solution of the small instance of the problem into single one. And the extend means we have to extend the solution which is obtained by combining the solution of sub problem instance into the remaining original problem. But in case of divide and conquer, we will divide the main problem into n number of sub problems of equal size, and then we have actual problem size, and then we have to combine the solution of the actual problem. So there is no need to extend the solution of the instance to the original problems. In that particular way, the design and decrease and conquer will be different from the divide and conquer. And this approach is also known as the incremental or inductive approach. So here we have to solve the problems by reducing the input size data of the problems or as instance at each step of the solution process. The main advantage is it is both time as well as space efficiency, because we have to decrease the input size of the each and every step during the solvation. And it is very important, but the main thing is it is very important to choose the right strategy for reducing the input size at each and every algorithm. If it is a poor choice means it can lead to an inefficient algorithm. So the approach we can able to approach the decrease and conquer into two way. The first thing is top down, and the second one is the bottom up approach. The top down approach is always leads to the recursive implementation of the problem, and the bottom up approach is usually is implemented in iterative way, starting with the solution to the smallest instance of the problem. And there are three major variations we can face in the decrease and conquer. The first thing is decrease by the constant factor, decrease by a constant, decrease by a constant factor, as well as variable size decrease. Here, and the decrease by constant means the size of the instance is reduced by the same constant on each iteration of the algorithm. Typically, this constant is always equal to 1. For example, for this is insertion sort graph algorithms such as the breadth first search and the depth first search, and topological sorting and algorithms for searching for generating permutation and subsets. The second one is decrease by the constant factor, which is nothing but reduce the problem instance by the same constant. For the first one, we have to decrease the by the same constant value on each iteration, but here we have to decrease the instant problem instance by the same constant factor. The constant factor is always equal to 2. It is very rare we can able to get the constant factor other than 2 in a very rare case. For example, for this binary search, fake problems, fake coin problems, Russian peasant multiplication. The third one is the variable size decrease. In this type, we can choose the size reduction patterns varies from one iteration to another iteration. For example, for finding the GCD of two numbers through the value of the second argument is always smaller than the right hand side of the than on the left hand side. So here we can decrease neither by a constant nor by a constant factor. Example for this is computing median and selection problems, interpolation search, Euclid algorithms. The first one is the next topic is for sorting problem is the insertion sort. Here It's a simple algorithm, sorting algorithm. We are going to sort the given list either in ascending as well as the descending order. It's like playing cards in your hands. What are the basic steps for sorting is, the first one is we can start with the second element, and as the first element is assumed to be sorted, compare the second element with the first one. If it is smaller means the first one is smaller than the second one means we can leave it, or otherwise we have to swap the first element. After the swapping we can move to the third element. So repeat the entire steps until the array is sorted. This is what a algorithm for a or a routine for our insertion sort. First, we have to get a length of the given array by using the length function. We have to iterate the steps for up to starts from 0, indexing 0 to n, entire list of the element n. The first one is we can assign the value of the first position in the insert index, and we have to get the current value by using the pop of the function. The second for loop is used for sorting the element in the array. If it is larger than the current value, it returns the value, or otherwise it can be swapped, and finally it will produce the printed sorted array. So this is what your time complexity graph for the insertion sort. Here the efficiency of the sort is O of n squared. Here we are going to use the two embedded loops. That's why the basic efficiency, based on the basic efficiency class, we can give the value of n squared. It is a O. So it is a run between the upper and the lower bound of the running time. So the it represents the worst case efficiency. So we can give it as O. So the time efficiency for insertion sort is O n squared. So the next one is the binary search. So the binary search is the fast search algorithm with the runtime complexity of n log n. So this works based on the principle of divide and conquer. Before searching, we have to divide the entire array into two halves. First, it will the important one is it will works only in the sorted form of the array. The binary search looks for a particular key by comparing the middlemost item of the collection. Here we are going to computing the median value of the array. So it represents the middle value. Then before the elements which is less than the median value is present in the left hand side, and the largest than the median value is present in the right hand side. So this is what the representation of the binary search of the element in the array. We are going to calculate the median value by computing the lowest value, that is 0 index plus the highest index 9 is divided by 2. 0 plus 9 is nothing but 0.5. So we have to take the value of as the median value of indexing 4. So before the that is just nothing but the left hand side of the middle value is always less than the middle value, and the right side is always representing the higher value of the middle element. So these are the basic conditions for applying the binary search algorithm. First, the data structure should be in a sorted form. Second, the access to any element of the data structure should take a constant time. So these are all the algorithmic steps. First, we have to give the input array of element n, which is represented in the array of A, and with the key element to be searched. The output will be, the algorithm will returns the index of an element which is equal to key value. Here we have to search the element which is present in the key indexing value. First, we have to assign 0 to the low variable and n minus 1 to the high variable. If the if the low variable is less than high variable, it will move into the loop. Here m is computing the median value. So we are going to compute by low plus high index divided by 2. If the key variable is equal to a of m, just nothing but the median of array, is then it returns the indexing of the array which is present in the middle element. Else it will check the key with the remaining values higher than the middle value. Else it is moved to the lower value. So this is the binary search algorithm. So first, by finding the middle index, it will divide the entire array into two. If the key is smaller than the middle element, it will use the left side for search, and if it is larger, means it is used for the right side to search the entire element. Thank you.